Are you going to record or what? Is it recording?
Yeah, it's recording.
Oh.
That's right.
Okay, what is the inverse of distributing? The opposite of distributing. It's factoring. The opposite of multiplying two binomials together is to factor them. So the greatest common factor of two constants is the largest factor they both have in common. The greatest common factor of two variable terms will be the base and the smallest exponent of the terms. So this sheet is going to kind of lead into how we factor. So what is the greatest common factor of 16 and 8? Be 8. 8 goes into itself and 8 goes into 16. It's the greatest common factor between the two of them. 24 and 16. 8 again, right? Where I'm coming up with these numbers, I'll do on the next one. If I was to break down the number tree like this, remember how to do that? What's the largest number that they both have in common? 3. That's what a greatest common factor is. So the greatest common factor between 8 and 18 is 2. How about these two? 10. 10 goes into 20 and goes into 50. Aha! Now we're getting into the stuff that we need to know. Okay, what is the greatest common factor between 36 and 9? 9. 9 itself. Now it's talking about the bases must be the same, so you take the base, which is x, and you take the smallest exponent, 2. X squared goes into x squared. X squared also goes into x to the 4th, making x squared the greatest common factor. Okay, number that goes into 36 and 12. 12. Take the smallest exponent, which would be
1.
good. Keep the base 1. 4 and 36. 4. I want to take the smallest exponent. I have x to the 9th and x to the 2nd. That's the smallest. Y squared and y squared. They're both the smallest.
That's, yeah, both smallest.
Yeah. Okay, what's the greatest common factor between 3 and 5? There isn't one, so we don't have one. Between x squared and x to the 9th, the smallest exponent is squared. Y squared and y squared, smallest one squared. Z to the 9th, z to the 7th, z to the 7th. So if I don't have a greatest common factor, I just don't write it. Between 30 and 5, greatest common factor is 5. Y squared and y squared. Why didn't I use the x to the 9th? Come on, I didn't use that. Yeah. Because it's the biggest. And the other one doesn't have the same base. Right? The other one doesn't have an x. so I can't use it. They don't have a greatest common factor, kind of like what you did with the 3 and the 5. Okay, between 4, 8, and 16, 4, x squared, x cubed, and x to the 4th. Smallest exponent is squared. 14, 28, and 21. What number goes into all of those? 7. I have x to the 1st, x cubed, and x to the 4th. Take the smallest one, x to the 1st. Can't tell how much time I have left. What goes into all of those? 2. Smallest exponent, x1, y1, right? Smallest number that goes into all those, or I shouldn't say smallest, largest, and it's 3. Y to the 1st. Okay. M to the 2nd. Cool. Cool beans. Now we're going to apply it. What is the greatest common factor between 2x and 4? 2. So I'm going to factor out a 2. 2 gets pulled out. If I pulled the 2 out, what am I left with here? What am I left with over here? 2. So this is the opposite of distributing. You notice if I distribute this, I'll get 2x plus 4. So I factored out a 2. 2x divided by 2 is just x. 4 divided by 2 is 2. What goes into both of these? 2. So I'm going to factor out 2 again. 4y divided by 2. 6 divided by 2. So if I distributed, I would get 4y plus 6. What?
So we're just undoing
Multiplication, yeah. Factoring is the opposite of the distributing. Number that goes into both of these? 6. 6 is my greatest common factor, so I put that out front. 12a squared divided by 6. 2a squared. 30 divided by 6. 5. Okay. What comes out of both of these? X. X squared divided by x would just be x. 2x divided by x is 2. If I distributed, I would get the same thing I started with. What goes into both of those? 5x. 10x squared divided by 5x is 2x. Negative 15 divided by 5x is just 3. Negative 3, sorry. That's a negative.